So I have a simple question for you. I've come up with a function, y is equal to 3x. I've written it down twice, once on the left and once on the right. And what I'd like you to do is interpret the two sentences here. So this sentence on the left says increase x by 10, solve for y. And I've given you some test values to start with. So when x is equal to 2, y is equal to 6. So that's where we'll start and then apply this sentence and solve for a new x and y pair. And then likewise over here, do the same thing. I've started with the same base values here. X is equal to 2 and y is equal to 6. And the same function, of course. And I want you to interpret this sentence. Increase x by a factor of 10, solve for y. There's a subtle difference in these two things on the left and on the right, and I want to see if you really understand this. So go ahead, pause the video, and see if you can solve correctly for both. All right, so hopefully you're able to do the one on the left pretty easily. You increase x by 10. That just means add 10 to whatever x was to start with. So x was 2, and if we add 10, we get x is equal to 12. And then when you plug in for x is equal to 12 into the function up here, you easily get y is equal to 36. So if you got that, you correctly interpreted this language, increase x by 10 to solve for y, and likely that was easy for you. Okay, so now over here on the right-hand side, we see this important language, increase x by a factor of 10. And that phrase, by a factor, is a very important phrase. And there's a subtlety there. These are almost the same sentences, but they have very different meanings. So what this means by a factor is it means to multiply by the number that the factor is. So in this case, the factor is 10, so we would multiply x by that factor. So instead of adding 10, we're going to be multiplying 10. So I'll put x as for the multiplication symbol, not the x up here, but just times. So times 10, okay, 10x times 10. So 2 times 10 is 20. All right, so we get a totally different value for x, and now y, of course, would be 60 when you solve for it. So this language has very important meaning, and I want to make sure you're aware of that. This, where we can say over here on the left, we call this additive thinking, where we're adding a certain value to x. And then over here, this is multiplicative thinking, where we're multiplying a certain value times whatever x is. And the language is subtle. Increase x by 10 versus increase x by a factor of 10. And it will turn out for us when learning physics that multiplicative thinking will be very, very helpful to simplify the analysis of a lot of our thinking. All right, just to make sure you see the difference between these two ideas, why don't you try this little practice problem? So pause, think, and try this. And hopefully it's self-explanatory just from my drawings, but in case it's not, we're going from x is equal to 10 to 35 in both cases through some process of change that we're not explaining why. Maybe it could be some physical process of height increasing from 10 meters to 35 meters, or maybe time going from 10 seconds to 35 seconds. It doesn't really matter. But x is increased by what here, and then x is increased by a factor of what here. So pause and see if you can get this. All right, so hopefully you got it here. When we increase x in this example, we're adding the number 25 to 10 to get 35. So x has increased by 25 in our additive thinking. And then that same going from 10 to 35, when you think about that in multiplicative thinking, by what factor have we increased x by? And that factor would be 3.5. So we'll put that down here, 3.5. The way you can simply always calculate these things is you just divide the final amount by the initial amount. So it's a ratio of 35 over 10 that gives you 3.5. And what you're really saying here is you're saying, let's take our initial x value. I can even put little I and little f there if you want. You don't have to do that. But if you take your initial x value and then you multiply it by that factor of change, in this case 3.5, that's the factor by which we're going to multiply whatever our initial x was. That's going to turn into, so this will go into, turn into our final x value. And if you just plug in the numbers, it works. So 3.5 multiplied by 10, let's do that right here, multiplied by initial value of 10, That's going to give us our final x value of 35. So hopefully these ideas are intuitive and easy for you, but there's some things that we need to be very crystal clear on with the language and the simple procedures of figuring out factors by which something is changed by versus these ways of additive thinking. All right, so we'll continue with building up our mathematical skills as time goes by, and hope you enjoyed this video.